Welcome back to the course of Foundation Engineering. The next topic, what we'll get started is with pile foundation. So in our earlier classes, we have in detail talked about what is meant by shallow foundation. And from this lecture, we'll be focusing on what is called as here deep foundation. So when we had an introductory lecture on how the foundations are classified, we said foundations are broadly classified as shallow foundations and deep foundation. So whenever you have hard bearing stratum which is available nearer to the ground at a shallow depth, we go for what is called as a shallow foundation. Whenever the soil that is available nearer to the ground is relatively soft or relatively weak in carrying the superstructural load, then we said we'll go for a foundation which relatively transfers the load into deeper depths into the ground. So such kind of foundation is what we call it as deep foundation. So in the process of understanding what is meant by deep foundation, we said it's nothing but a foundation which relatively transfers the load coming from the superstructure onto the deeper strata of the soil, okay, either by mechanism of what is called as friction around the surface of that deep foundation, or in the form of what is called as load transfer directly from the base of that particular deep foundation. So that's how we have talked about how the load transfer takes place through that particular deep foundation. And then we have understood how the deep foundation is classified. We said deep foundations are broadly classified as pile foundation. So we have subsequently understood it as your well foundation, which is otherwise also called as caisson foundation. And we have also talked about a temporary structure which is constructed to take up the construction of what is called as your deep foundations in the water body areas. Okay, so which is what we call it as cofferdam structures. Okay, these cofferdam caisson structure, these parts will be discussed in our fifth unit, and in the fourth unit our main focus would be on understanding what is meant by pile foundation. So let's quickly go through what we have already discussed in our earlier lecture, where we have talked about the introduction to the foundations, where I have already talked about little in detail regarding how what is meant by pile foundation, how the classification of pile foundation is done depending on various criteria. So let's look at the same quickly to understand briefly about each of those aspects what we have already touched upon. So what is meant by pile foundation? So pile foundation is nothing but it's a foundation where the depth of the foundation is greater than the width of the foundation. So such kind of foundation, in general, what we call it as your deep foundation. So as pile foundation is one such a type of deep foundation. So pile foundation is otherwise also nothing but we call it as whenever your depth of the foundation is greater than the width of the foundation, I'll be typically calling it as your deep foundation. And particularly if the diameter of that particular deep foundation is less than that of 1.5 meters or so, around 1.5 meters or so, we call that as your typically the pile foundation. So pile foundation is nothing but it's called as a slender member, slender structural member. Why do we call it as a slender structural member? Whenever the L by D ratio of that particular pile is relatively high, okay, L indicates the length of the pile, D indicates the diameter of the pile. So whenever the L by D ratio of the pile is greater than 10, we call such members as your slender members. So pile is nothing but typically a slender structural member which is made of either timber material or steel material or concrete or whatever different composite materials which are being widely used in the construction of your foundation. This is typically suitable for transferring building loads to underlying firm ground wherever you have hard strata available at deeper depths. So in such case, so these kind of foundations are typically used for transferring the superstructural load. It is installed in the ground to transfer the superstructural load to soil at some significant depth below the base of the structure. So, and these kind of foundations are suitable relatively in the cases where the soil is soft or the superstructural load what is coming is relatively heavy. And pile is nothing but it's a part of your substructure, what we call it as. And whenever we talk about this particular pile, we have got different ways by which the construction of the pile is taken up. Okay. Ultimately, the pile, whatever we are trying to talk about, is installed in the ground, is constructed and placed in the required site position, or directly constructed in the required site position by placing it either vertically or by placing it in inclined direction to transfer the loads which are coming from your superstructure. As we have already understood that never the pile is provided individually to carry the superstructural load. So what we try to do is piles are provided in group action where all those individual piles are structurally connected by what is called as a pile cap. So where this pile cap is nothing but it's a thick slab which is used to connect the individual piles to form what is called as a group action in carrying the load which is coming from your superstructure. We have different types of loads that are coming onto your pile foundation. It's not only in typical case of pile foundation, even in the case of shallow foundation also, we come across with similar kind of loading conditions. It is the different types of loads what are considered in the design of those foundations are nothing but dead loads, live loads, wind loads, seismic loads, that's nothing but the earthquake load, are the loads coming because of your traffic, moving vehicles, or water pressure forces, etc. So all these different types of loadings are considered in the design of your foundation. So is it that all these loads are considered every time? It is not so. So depending on the case for which structure you are taking up the design of that particular pile foundation or deep foundation. So depending on that, okay, if it is that particular pile foundation what we are talking about is for a building, so there I need not consider what is called as your traffic load. I need not consider preferably what is called as your water pressure. Okay, and depending on the zone where it is, where that particular structure is being constructed, whether it falls in earthquake zone 2 or 3 or 4 or 5, depending on that, the earthquake loading is considered. So based on the place, type of structure, okay, considering various other factors, you will be taking into consideration of what type of loads that are to be chosen and considered in the design of that particular foundation. And coming to the different types of loading mechanisms, okay, so ultimately what type of load gets transferred onto your pile foundation, if I need to understand, it will be what is called as your vertical loading. Vertical loading in the sense, it's not always only the vertical compression load, that means the downward force acting on the pile foundation. You'll also see some cases where your uplift forces would also be acting on that particular pile. So such kind of loading is what we call it as uplift forces, or we also call it as tensile forces acting on your pile. So this vertical loading what we are referring to refers to that of two types of cases. One is your vertical compressive load and the other is your vertical uplift force. Okay, so this uplift force, or we also call it as tensile load, which tries to lift your foundation in the upward direction. And we'll also come across with what is called as lateral loading. So lateral loading in the sense, your horizontal load which is acting on that particular pile foundation. And whenever you come across with such kind of lateral loading condition, along with that lateral load, you might also get ended up with moment of couple getting generated on that particular pile foundation, which would also be considered in the design of the foundation. Now, coming to the classification of the piles, how the piles are generally classified as. So, based on various criterions, these particular piles are classified. So, one of such criterion is based on the function for what purpose that particular pile is constructed there. Whether it is constructed there to take care of your vertical compressive loading or vertical uplift forces, or whether it is to be constructed there to take care of the loads which are coming from the water pressure at the sea coast region, or whether that particular piles are constructed to take care of your what is called as densification of the soil. Okay, whether that particular pile what we are trying to talk about transfers the load only from the base of the pile, whether that particular pile transfers the load along the shaft region of the pile, that's nothing but along the surface of the pile. So depending on that, based on the functionality aspect of that particular pile, we classify the piles as load bearing piles, or otherwise we also call it as end bearing piles, frictional piles, and sometimes we also use the notation as skin friction piles, because skin friction in the sense on the surface of that particular pile, along the surface of that particular pile, resistance will be getting developed to carry the superstructural load. And tension piles are uplift piles, piles subjected to what is called as your uplift forces. Sheet piles, anchor piles. Sheet piles in the sense these kind of piles are used in the construction of your retaining structures to prevent your failure of the slopes in the retaining soil, which is to be retained before the construction of your retaining structure, or maybe in the cases of open excavations that you are required to carry out in the construction of your foundation. In such particular case of carrying out the open excavation, there are all possibilities that the surrounding soil might get collapsed into that open excavation. So to prevent that, we provide some sheets which are driven into the ground. And in some particular case where you do not want to allow the seepage to happen through the cross section of the soil strata, so to prevent such seepage also, you can try to drive your sheet piles into the ground, so that you can minimize your seepage losses and so on. So these anchor piles are nothing but these are a typical type of piles. Here the piles are not going to be carrying the superstructural load, but they are going to be acting like resisting members against the lateral displacement, which is expected to happen in that particular structure or the structural elements. Batter piles are nothing but we call them as your inclined members. As earlier I was saying, piles are not always placed vertical. Sometimes the piles are also placed in inclined direction. So that inclined oriented piles are nothing but we call them as your battered piles. Okay, batter piles, which is also called as inclined piles. Sometimes we also call it as secant piles. Okay, so the purpose of this batter piles is to take care of your both vertical load and the lateral load, which can be carried by that particular pile individually. We come across with what is called as this Fender Piles, which are basically used in the construction along your sea coast area. Okay, where to take care of the forces coming from your moving ships or water wavefront. Okay, so to take care of the loading, so such kind of piles are used in the construction there, which are called as your Fender piles. And compaction piles. The purpose of these piles is to stiffen the ground condition, to improve your ground condition, to improve the bearing capacity aspect of that particular soil. We are going to be using not the large diameter piles, they're smaller diameter piles. Typically the diameter of the piles there in such cases less than 300 mm. So such kind of piles we will be using there in the ground to install. And by driving such kind of piles into the ground, there we are trying to improve what is called as the stiffness of the soil there. So let's understand each of those aspects in detail. So load bearing piles are end bearing piles. These piles are typically used to transfer your superstructural load into the deeper strata. Okay, so these piles are driven into the hard ground until these piles are driven into the ground until a hard stratum is reached. So till wherever you have your hard stratum, till that particular depth, these piles are extended. So as the name itself says, the pile is going to transfer the load only from its end. So the end has to be obviously placed on what is called as a hard stratum, so that the load, whatever is coming onto this pile, gets transferred from the base of the pile onto the hard stratum. Acts as pillars supporting your superstructure and transferring your load onto the harder soil strata wherever it is available. That's what we call it as your load bearing or end bearing pile. Next is frictional piles. Frictional piles are otherwise also called as skin friction piles. Here in this particular case, piles are driven at a particular construction site where the soil is relatively weak or soft, where you cannot extend that particular pile in search of what is called as a hard stratum, which is relatively available at a very far depth. So in such particular case, even in the form of your skin friction also, there will be some resistance that gets developed from your pile. So in such particular case where your soil is soft and the hard stratum is available at a very far depth, so by a mechanism of what is called as skin resistance or frictional resistance, the load which is getting transferred onto this pile can be resisted. So such kind of piles is what is called as your frictional piles or skin friction piles. And tensile piles are uplift piles. They are nothing but the piles which are subjected to uplift forces. So such kind of piles is what we call it as your tensile piles or uplift piles. So whenever you have expansive soil, because of the expansive nature of the soil, you will see the possibility of pile getting lifted in the upward direction, foundation getting lifted in the upward direction because of the action of your expansive nature in the soil. Or sometimes in the electrical transmission towers, where the cable, the tendons which are placed over the top of your electrical transmission towers, if those tendons are pulling that tower onto one direction, then the piles which are there below that electrical transmission tower starts getting lifted in upward direction. So such cases is what we call it as the pile subjected to what is called as your uplift forces. Sheet piles. So these are typically nothing but steel sheets. It need not be steel sheets. Okay, it can also be some plastic sheets or fiber sheet material, which are used in the construction of your retaining walls at dockyards or dockyard structures and other marine regions where you have your water bodies existing. So these sheets can be driven into the ground to ensure that the water do not directly come in contact with the other side of the soil what is available, and you can easily take up your subsequent construction, because the sheet what you are going to be driving there acts like an impervious material and prevents the seepage of your water from one side to the other side through your soil strata. And these sheet piles can also be used to protect to prevent what is called as your erosion of your river banks. It need not be only along the river banks. It can be anywhere wherever you have your water bodies available. So in order to prevent the erosion of that particular soil bed what is available, okay, so to prevent the erosion of that soil bed, you can drive these sheets into the ground adjacent to that particular river bank, and water wherever it is in contact, there you can drive that sheet piles into the ground to prevent the so-called erosion in the soil what is available adjacent to the water body. To retain the sites of your foundation trenches, so whenever you are making some open pit excavations, so to prevent the failure of that soil in the process of making the open pit excavation, so you can drive these sheets into the ground, which are basically called as your sheet piles, which prevents the relative displacement happening in that particular soil adjacent where you are taking up your open pit excavation. And coming to what is meant by anchor piles, these piles are nothing but which are used as anchorage against horizontal pull from sheet piling wall or other pulling forces. For example, if you are trying to place only a sheet pile, there is all possibilities that the force exerted by the water, if it is more, then the sheet pile can get dislocated from its position. You will be seeing a deflection happening in the sheet pile because of the pressure exerted by the water. Or in some case, if the pressure exerted by the soil on the other side, if it is more, there is a possibility that the sheet pile will not be in its own position how you have installed. Rather, you will be seeing the failure getting developed in such kind of sheet pile. So in such particular case, to prevent the failure of those sheet pile, what you can try to do is, you can try to have some members which are driven into the ground through this sheet pile, so that these members which are driven here acts like what is called as anchor. Okay, so here we are also going to be constructing the piles which would act like anchoring mechanism, which can minimize what is called as a horizontal displacements, which are expected to be getting developed in your structural elements or in your foundation elements what you are trying to construct in the field. So this is how typically your end bearing pile looks like, where the load whatever is coming onto this pile is transferred only through the base of that particular pile. And this pile is typically what we call it as your frictional pile, where the load what is getting transferred onto this pile is resisted only in the form of the friction on the surface of your pile. And this pile is what we call it as your tension pile or uplift pile, where this pile is subjected to what is called as an uplift force. And when the action on the pile is in the upward direction, obviously the reaction in the form of the skin friction would be getting developed on the surface of the pile, but which is going to be in the downward direction. And this is a case of what is called as a sheet pile. You can see a blue sheet which is driven into the ground. So to take up any particular construction according to your requirement. Yeah, this is another typical case of what we, this image talks about another typical case of what is called as a sheet pile, which is driven into the ground. And the purpose of driving that sheet pile into the ground can be for various reasons, for taking up any construction on one side, preventing the adjacent soil failure, or it could be for various other reasons, depending on the requirement, what you are looking at. So here also, you have some typical set of sheets which are driven into the ground, are placed, and you have some anchoring members. You have some inclined members which are existing there here, which are acting like anchors, which are holding those sheets in preventing the lateral displacement in those structures, so that these sheets are going to be acting like the barriers to prevent the seepage of water, or maybe for storaging of water. So purpose could be anything. So you can meet that particular purpose with the help of some anchoring mechanism additionally introduced to that set of your sheet piles which are placed there. So based on its function, we'll also call a pile as a batter pile when those piles are driven or installed in the ground at certain inclination to resist not just only your vertical force, but major aspect here is to take care of what is called as your horizontal loading and as well as your inclined forces. So whenever we say inclined force, it's a component of what is called as the vertical force and the horizontal force, which is expected to be coming on such particular piles. So in such particular case, you can go on to have a pile which is typically called as an inclined pile or a secant pile or a batter pile, where that pile is going to be placed at certain inclination depending on your requirement and the intensity of the load what is coming on to that particular pile. And another type of pile is Fender pile, where these piles are used to protect the concrete deck, the concrete slab what you are going to be constructing, or any other waterfront structures from the abrasion or impact caused from your ships. Whenever you have your ships moving towards your shipyards, so in the process, there will be an impact force which gets generated from the waterfront, water wave moment on the concrete deck or the concrete structure what is existing there. So in order to prevent such failures what are expected to happen due to that impacts caused due to the ship's movement towards your shipyard or any other particular place where your unloading and loading of the goods are going to be carried out. So in such particular case, these Fender piles acts like a barrier in the front. So those forces will be taken care by this particular piles which are installed in the front. Next is compaction piles. So these particular typical type of piles are called as smaller diameter piles, or otherwise we also call it as micro piles, which are driven into the granular soil deposits mainly. So in order to strengthen the bearing capacity of that particular soil, if that particular granular soil is a loose soil deposit, so in order to improve the ground condition there, you can drive a smaller diameter piles directly into the ground, which acts like the stiffeners to that particular soil. If you look at this particular pile, okay, this pile is what is called as your Fender pile, because these piles are constructed immediately in the starting of your concrete deck, whatever is available, so that any ship movement here, the forces which are generated because of the ship movement will be resisted by those Fender piles which are going to be placed. And this type of pile, see, it's not that all these piles are going to be at a place. Just to give you an idea how those piles are going to be and why those piles are going to be placed, we are just trying to look at this particular image. Okay, so this pile is nothing but I'll be calling it as your foundation pile. The purpose why I'm calling it as a foundation pile means it is the functionality of this particular pile is to take care of the loads coming from your superstructure. That is why we call it as foundation pile. Here, this pile is nothing but we call it as a sheet pile. The purpose of this to be called a sheet pile means the soil what is there here is getting prevented from having the failure. Okay, so that's the reason why we are calling it as your sheet pile. And this pile I can call it as a batter pile because that pile is placed at certain inclination with a vertical. So such kind of pile is what is called as a batter pile. And this pile is what I can call it as your anchor pile. Anchor pile means it need not be always placed horizontally, or it need not be placed in the inclined direction as an anchorage to the existing sheet or existing any vertical member to prevent what is called as your horizontal displacement in the structure. So it can also be, those anchor piles can also be placed in the vertical direction depending on the requirement and the problem that you are dealing with. The position of the anchor pile, the orientation of the anchor pile is getting changed. And based on the size, how we are going to be classifying those piles means they are classified as micro piles. When the diameter of the pile is less than 300 mm, we call those piles as your micro piles. And the purpose of those micro piles is only to strengthen the ground there. And we typically call the deep foundation members as piles whenever the diameter of the piles is approximately around 0.3 or 0.4 meters to 1.2 to 1.5 meters. So such kind of deep foundation members are called as piles. And if the diameter of the pile, if the diameter of that deep foundation is greater than 1.5 meter, we typically call it as your large diameter piles. And further, if the diameter of that deep foundation is greater than 5 meters, we call it as your well foundation or pier foundation, or otherwise caisson foundation. Based on the loads, how do we classify the piles means? Piles which are subjected to what is called as compression loading, piles which are subjected to what is called as uplift loading, piles that are subjected to what is called as your lateral loading. And based on the material that is used in the construction, okay, we can come across with what is called as concrete piles, we can come across with what is called as steel piles, we can come across with what is called as timber piles, depending on the material that is used. If timber material is used, we call them as timber piles. If steel material of different cross-sectional shapes, of H-shaped cross-section or cylindrical shaped cross-section or tapered cross-section. Tapered cross-section in the sense where the cross-sectional area of the pile is getting changed with the depth. Okay, so such kind of piles are what are called as tapered piles. So this kind of pile is what is called as your tapered pile, where the cross-sectional area of the pile is not constant throughout the depth. Yeah. So even in the case of concrete piles also, whether those concrete piles are cast in situ in the sense at that construction site, are you preparing that concrete pile, or is it fabricated somewhere else and brought it to the construction site and then installed? So whether that particular concrete piles are cast in situ, or whether that concrete piles are precast, somewhere casted in casting yards, brought it to the site and directly installed. If it is cast in situ also, whether that the process of construction of the pile there is done by providing a casing while making the borehole into the ground, or without providing a casing while making a borehole into the ground. So we sometimes provide casing, sometimes we don't provide any casing. If the soil is stiff, I don't require any casing to be provided. Why? Because when you are making the borehole, the soil in the surrounding of that borehole will not get collapsed into the borehole region what you are extending there, if the soil is relatively stiff in nature. Okay, but however, if the soil is soft, in such particular case, there are all chances that soil starts collapsing into the borehole. So to prevent that, we try to provide a casing. It's a hollow cross-sectional member which is driven into that borehole, which is placed into the borehole, so that that hollow cross-sectional member do not allow the adjacent soil to get collapsed into that borehole what you are extending there. And based on the type of construction, okay, whether that particular pile is driven into the ground, which is called, while driving that pile into the ground, whether that soil is laterally getting displaced or radially getting displaced while pile is driven vertically into the ground, or pile is driven in inclined direction into the ground. So such kind of piles are what are called as displacement piles, or otherwise I can also call them as driven piles. So all those driven piles are going to cause, when you are trying to drive the pile into the ground, they are obviously going to cause the displacement, radial displacement happening in your soil grains, which are coming in contact with the pile which is getting driven into the ground. So such kind of piles are also called as driven piles or displacement piles. Now what is meant by non-displacement piles? So these piles, when they are installed in the ground, placed in the ground, the surrounding soil is not at all laterally getting displaced or radially getting displaced. So such kind of piles are called as your non-displacement piles. So the piles which are constructed by making a borehole into the ground are all called as non-displacement piles, because in this particular installation of piles, you don't see particles radially or laterally getting displaced in the process of construction of such particular pile. Now, what are the different reasons for the failures that generally happens in your piles? Okay. So, what could be the probable reasons because of which the failure happens in your piles or pile foundation means? So, because of the unequal settlements in your subsoil strata, so because of that unequal settlement, you would be coming across with what is the terminology called as differential settlement, is what we generally call it as unequal settlement, otherwise also called as differential settlement in that particular foundation of the superstructure. So, because of which there will be the failure that you will be coming across in the foundation there. Whenever your horizontal movement of the soil adjacent to that particular structure, whenever the soil adjacent to the structure is horizontally getting displaced, whenever you find such kind of condition prevailing, then we say your pile, whatever is going to be constructed there, is having a chance of undergoing the failure. Whenever you have change in the volume of the soil, which is available below the superstructure, due to change in moisture content in that particular soil below the foundation. So, because of that effect also, you'll be seeing the failure happening in that particular piles. Whenever the lateral pressure tending to overturn the structure, whenever the lateral load that is coming from the adjacent soil or the adjacent structure, whatever is available, so because of that lateral load what is coming onto that particular pile, there are all chances that if the piles are not properly designed, you will be seeing your overturning effect happening in the superstructure, resulting in the failure of your foundation there. And because of the action of atmosphere in the sense, if you have your glaciers or if you have the effect of wind loads, snow loads, okay, so if those are not properly taken into the consideration, depending on the location where you are constructing your foundation, so there are all possibilities that your superstructure gets damaged because of the failure in your pile, because the pile is not designed to take care of those loads. Because of lateral escape of the soil below the foundation, due to the soil whatever is there below the foundation, sometimes what happens is, whenever there is a large seepage of water happening into the ground, so in the process of large seepage happening into the ground, the particles also gets carried away with the water in the process of seepage. Soil grains also gets carried away in the process of seepage happening in the ground. So in such particular case, if the soil whatever is there below the foundation, okay, in the region of the foundation, if it is getting escaped, soil grains are getting escaped because of any reason, okay, so in such particular case also you will be seeing the failure happening in your structure. These are some of those particular images which talks about the failure in your superstructure resulted because of the failure which took place in the structure because of the failure in the foundation. Okay, so the foundation has failed, because of which your superstructure is getting tilted or getting settled more than that of the permissible settlement, or you will be seeing complete overturning effect happening in that particular structure, resulting in what is called as your failure of your structure. Okay, so this is all something about a quick review of what we have already learned about the deep foundation, that's particularly your pile foundation. And from our next class, we'll be focusing on how do we calculate the load bearing capacity of an individual pile, which is subjected to what is called as your compressive loading, which is subjected to what is called as an uplift force, which is subjected to what is called as your lateral loading. So under these individual conditions, what is the load carrying capacity of a pile, we'll try to understand. And then we will move on to understand what is the load carrying capacity of your group of piles which are structurally connected by means of what is called as a pile cap. Okay, so with this, we'll be stopping our discussion for today, and we'll be continuing our discussion in our